In this video, we'll talk about how to factor ax squared plus bx plus c. What's different about section 10.6 and 10.5 is that we'll have a value here for a. So in 10.5, the value of a was 1. In 10.6, a will have a numerical value of something other than 1. So in our first example, we have 3x squared plus 17x plus 10. So to factor using the grouping method or the distributive property, which is what this video is going to show you how to do, the first step I need to do is multiply a times c. So a is 3 and c is 10. So a times c is 30. So I need to think of the factors that multiply together to give me 30, but add to give me my b term. So in this case, it's going to be 17. So when I think of what those factors might be, I'm thinking that my factors are 15 times 2, because 15 times 2 is 30, and 15 plus 2 is 17. So I'm going to rewrite my trinomial as a polynomial. So I'm going to rewrite it as 3x squared plus 15x plus 2x plus 10. And basically the reason I'm doing that is I am expanding 17x. So I can write 17x as 15x plus 2. So if I were to combine like terms or simplify the expression I just made, I would get my original trinomial. Now I'm not factored just yet, but that's where we're going here, or that's how we're starting, I should say. All right, so what I need to do now is I need to put parentheses around the first two terms and my second two terms. I'm just going to draw a squiggle here so we don't get all those numbers mixed up. So when I draw when I put parentheses around the first two terms and the second terms, I need to ask myself, do I have a greatest common factor here? And in fact, I do. My greatest common factor of 3x squared and 15x is 3x. So I can factor out a 3x. When I do that, I divide each term by 3x. So I'll be left with x plus 5. So I just factored this first binomial into this. 3x times x plus 5. Now I'm going to do the same thing over here. And my trick here is that when I factor this, part of the problem needs to look like x plus 5. So if I take out the GCF 2, I will be left with, so when I divide these terms by 2, x plus 5. So when these two binomials match, I know I did my factoring correctly. So to write my final answer, it's kind of like the reverse distributive property. I'm going to put 3x plus 2 is one binomial. 3x plus 2. And then I'm going to write singly x plus 5. So I'm going to write this down here. So this is my final answer. 3x plus 2 times x plus 5. To check my work, I can always use the FOIL process to FOIL out my two binomials that I'm multiplying. And if I get my original trinomial up here, I know I did my work correctly. Okay, here's another example of factoring ax squared plus bx plus c. So I've got 2x squared minus 11x plus 15. So I'm going to start the same way I started in my first problem. I'm going to multiply a times c. When I do that, I get 30 again. So I need to think of the factors of 30. So what numbers multiply to give me 30, but add to give me negative 11, my b term. So when I think about what those numbers might be, I'm thinking that it's going to be negative 5 times negative 6, which will give me positive 30. But when I add them, negative 5 plus negative 6, I'll get negative 11. So I need to rewrite this trinomial as a polynomial. So I'm going to write 2x squared minus 6x minus 5x plus 15. Now I want to go ahead and I want to group the first two terms and the second two terms. And I want to be careful here because I have a subtraction sign. So I don't want to lose that or forget about that negative. So for some of you, it might be best at this point to go ahead and change that to add the opposite so you don't lose that sign. Okay, I want to go ahead now and I want to pull out my greatest common factor from each binomial. So take out the GCF here and here. So my GCF of 2x squared minus 6x is going to be 2x. All right, when I take a 2x out, I'm going to be left with 1 minus 3x. I'm sorry, 1x minus 3. So that's a 1x minus 3. Now, what I want to have left over here is I'd really like x minus 3. So in order to make sure that this matches my first binomial, I'm going to make that x minus 3 there. That means I'm going to have to factor out a negative 5. So just to double check my work, if I were to distribute the negative 5 here, negative 5 times x is negative 5x. Negative 5 times negative 3 is positive 15. So I know I did my work correctly. Okay, now I'm going to go ahead and assemble my two binomials. So I'll be left with 2x minus 5 times x minus 3. And again, to double check my answers, I can I can go ahead and FOIL out my two binomials and see if I'm left with the original trinomial in the problem. Lastly, I always want to double check and make sure I don't have any greatest common factors left inside my two binomials that are remaining.